This video tutorial will review the method of dimensional analysis. Before we get started, please make sure you have a calculator handy. Dimensional analysis is a method of problem solving where conversion factors are used to cancel out units. And this definition is great, however, if you don't know what a conversion factor is, then it makes it hard to make use of this method. So let's take a look at that term. A conversion factor is a fraction where the quantity present in the numerator and the denominator are the same amount but expressed in different units. So what I want you to remember is that it's very simplest. A conversion factor is just a fraction. So it's got a quantity in the numerator and in the denominator, and they're the same amount, but they're in different units. For example, we know from working with the English system for many, many years that 12 inches is the same amount of length as 1 foot. So there are two ways to write a fraction from that information. We can write 1 foot is the same thing as 12 inches, or we could flip that around and have it written the other way. 12 inches is equivalent to 1 foot. So whenever you're writing a conversion factor, make sure that the quantity present in the numerator and the denominator are the same amount. And we know that 1 foot and 12 inches are the same. Now, how do you use these? When we say that conversion factors cancel out units, imagine you are sitting in a math class and you have the fraction 1/3 times 3/4. We know that we could simplify this calculation by eliminating the 3's, crossing out the 3's. And you can do that in a math class because when you're multiplying by 3 over 3, you're really multiplying by 1 and it doesn't change your problem at all. So you can cross numbers like that out in a math problem. You can also do it with units or labels, and that's what dimensional analysis is really about. So we're going to work through some examples to show you how dimensional analysis works. This first example, it says how many yards are there in 17.8 miles. Now, one of the things when you set up your dimensional analysis problems is you always want to take the given number in the problem and write it as your starting number. So 17.8 miles. And if you want to abbreviate miles, I would suggest that you do it MI, not M, because that would be meters. And then when we do dimensional analysis, we kind of work through our problem in a grid-like fashion. And whatever label we have in the numerator, in our given number, we want to cross out eventually in the denominator. Now for this problem, I'm trying to get to yards. That's my desired unit or label. And I know that there are 3 feet in 1 yard, but that doesn't really help me because I have miles here to start with. I need something to cancel out with miles. Now 1 mile is equivalent to 5,280 feet. So if I look at 2 pieces of information that might be helpful, these 2 conversion factors, we know that the second one is the one I should probably use first because I have miles here in my given quantity. So I'm going to write this piece of information as a conversion factor. And since I have miles on the top, I also want to put it on the bottom. So I'm going to put 1 mile on the bottom. That's equivalent to 5,280 feet. And in that process, if I kind of keep track of my labels here, miles will cross out, and so far I would have feet. But I wasn't asked to find feet in this problem. I was asked to find yards. So then I would use my other conversion factor. 3 feet is equivalent to 1 yard, and I want you to think about where that feet should go. Since I have feet here in the numerator, I'm going to put 3 feet in the denominator. That's equivalent to 1 yard, and the feet will cross out. Now, in these setups, every time you see a vertical line, okay, like across the top right here, that means multiply. Okay, so I would take on my calculator, and you should do this along with me, 17.8 miles times 5,280 feet. And if you wanted to take it times 1, you could, but you multiply across the top, hit enter, and then every time we see this horizontal line, that means that we have to divide by the numbers that are in the denominator. So I'm going to divide by 3. And so again, mathematically speaking, 17.8 times 5,280 feet, and then that answer divided by 3. And I should come up with 31,328. that would be yards, because the miles are gone, the feet are gone, leaving only yards. Now, we did learn about significant figures, and we do want to round to the proper number of sig figs. So since 17.8, our given number, has 1, 2, 3 sig figs, I'm going to round this answer to 3 sig figs. So the 3 will be my first sig fig, the 1, and then I'll round to this next spot. Now, I do have students that tell me the answer should be 313, because that has 3 sig figs. However, 313 is nowhere near the length of 31,328. So remember, we're rounding to this spot. We don't just cut off the rest of the number. So the question really is this answer closer to 31,300 or 31,400? And based on the 28 at the end, I'm going to say it's closer to 31,300. So with proper sig figs, that would be my answer, 31,300. Now, I'm well aware that you could probably do this problem just by crunching out things on your calculator. But I really want you to refrain from doing that, because as we work with more and more labels and units in this class that we are less familiar with, things like moles and calories and joules and things like that, we want to be able to fall back on this method, and it's probably the single most important method to learn for use throughout this entire class. So let's take a look at another example. 2. A distance is measured to be 56,450 yards. What is this distance measured in kilometers or kilometers? And so if I think about what I might know to help me do this problem, I know that I want to change 56,450 yards into kilometers. And in class, we distributed a little strip of paper that had several conversion factors on it. And one of the useful pieces of information on there would be the fact that 1 mile is 1.609 kilometers. Okay. Earlier, we also saw 1 mile is equivalent to 5,280 feet. Now, we are starting with yards. One thing that's not listed on the conversion factor is just the fact that 1 yard is equivalent to 3 feet. And so, just like the previous problem, we want to start with our given piece of information, 56,450 yards. And given all this information up at the top here, I can see that yards is what I'm going to have to go with first. So since yards is in the numerator, I'm going to put 1 yard in the bottom and 3 feet in the numerator. Yards in the denominator, feet in the numerator. And yards will cross out, and now I would have feet. So I've used this conversion factor. Of the ones that I have left, this is the one with feet, and you should be thinking to yourself which one I would want to put in which spot. So feet at the top, we also need it on the bottom. So 5,280 feet is equivalent to 1 mile. Feet will cross out. And then the last conversion I will use is this English to metric conversion. The fact that 1 mile is the same as 1.609 kilometers. On your calculator, and do this along with me please, you would take 56,450 times 3 times 1.609 kilometers. Then you hit enter, and then you would divide by the number in the denominator, 5,280. And you should get something like 51.6068 or something like that. This given number, 1, 2, 3, 4 sig figs. So I would round this 51.61 kilometers. Now there are multiple ways to do this problem. So if you used a different combination of conversion factors, that's just fine. But you should end up with a number that's either exactly this number or very, very close. I think a student mentioned that they used the conversion factor on their given list instead of 1 foot is 30.48 centimeters, and they came up with 51.62, which is just fine. At this point, if you've been following along, I would encourage you to pause the video and try this next example, example 3, how many kilometers in 8.23 yards. And if you don't have a conversion sheet in front of you, one of the useful pieces of information is that 1 foot is 30.48 centimeters. So I'd encourage you to pause that, go ahead and and try the problem, and then when you're ready, go ahead and restart the video and you can check your work. So hopefully you've had a chance to try this one out. The given piece of information here is 8.23 yards, and oops, common mistake, people like to write 3 yards and 1 foot, which obviously those two are not the same. So we would go with the conversion factor 3 feet in 1 yard, so 1 yard on the bottom, 3 feet, and then I would make use of this given information, the fact that 1 foot is equivalent to 30.48 centimeters. Yards will cross out, feet will cross out, and if you multiply across the top, you should end up with 753 centimeters. And again, my answer is rounded to 3 sig figs because my given information has 3 sig figs. Kids have asked me, well, you know, this conversion factor, Mrs. Hohenstein, has only 1 sig fig, so why didn't you round it to 1? In this problem, or in any calculation in science, we always want to round our number to that of the sig figs of the measured quantity. And to do this problem, I did not measure the fact that there are 3 feet in 1 yard. That's just a definition that you've memorized along the way. Things like 12 inches is equivalent to 1 foot. We didn't measure that. That's a defined quantity or a defined conversion factor. So 99% of the time, we're always going to end up taking our sig figs from the given information. Now, there's one other type of introductory problem that we want to take a look at for dimensional analysis, and that's with a little bit more complex unit. In this example, it says you are driving your car at 55 miles per hour. What is your speed in meters per second? Now, in math classes along the way, you've probably listed 55 miles per hour as 55 mph. And that does work fine in some circumstances, but when you're doing dimensional analysis, it's not very useful. So when you start with your given information for a problem like this, I would make sure that when you see miles per hour, that per you should think of as kind of, you know, helping you decide the 2 parts of the fraction. It's 55 miles for every 1 hour. And if you set it up that way, it makes it a little clearer which label and number are in the numerator and which ones are in the denominator. For this problem, we're going to make use of some conversion factors that we have seen previously. 1 mile is 1.609 kilometers. And then speaking of kilometers, we talked about that prefix before when we talked about the metric system. 1 kilometer would be 1,000 meters. So those are some things I'm going to make use of in this problem. Now our overall plan is to take 55 miles per hour and convert it into meters per second. And if you think about that, I have a length label or unit, miles, which has to be changed to meters, and I have an hours or a time unit that has to be changed to seconds. And it really doesn't matter which one you do first or second, we just have to do both of them. So 55.0 miles per hour. And we're going to set up our grid. I'm going to work with miles first. So I know 1 mile is equivalent to 1.609 kilometers. Miles go away. Kilo means 1,000, and so 1 kilometer is 1,000 meters. And then kilometers cross out. And if I stopped at this point, I would have meters per hour. So I have to work with time. Hours, from your common everyday experience, we know that 1 hour is equivalent to 60 minutes. Now, a lot of students get confused on which one to write where. If you go back to the beginning of the problem, hours is in the denominator. It's on the bottom. So that means to cross it out, I'm going to have to put hours on the top. So I will write 1 hour here, equivalent to 60 minutes. Hours from way back in the beginning, and this hour will cross out. And then I have to get to seconds. And we know that every 1 minute is equivalent to 60 seconds. So the minutes will cross out. And that's all the labels we should need to worry about, because I would be left with meters per second. Now if you crunch this one out, you're going to have to be careful. There's 2 numbers in the denominator. So you should confirm with your calculator that if you solve for this one, It should be 55 times 1.609 times 1,000. Okay, you'll get that much. Hit enter. And then when you do divided by, make sure you put this part in parentheses. Okay, so divided by and then left parenthesis, 60 times 60, and then end parentheses, and then hit enter, and you should confirm that you get the correct answer. It should be, to three significant figures, 24.6 meters per second. Okay, so now that you've seen a problem done with kind of this complex unit, where there's both a unit in both the numerator and the denominator, I want you to try this final problem. Last example says your car's gas mileage is 28.5 miles per gallon. What is the gas mileage in kilometers per liter? And from the previous problem, again, these are on your conversion factor sheet. 1 mile is 1.609 kilometers. And for volume, in terms of conversions, 1 gallon is 3.78 liters. So we're going to, you would pause the video, go ahead and try that, and then when you're done, go ahead and check it out. And hopefully you've had a chance to try that. So 28.5, and I'm going to write that miles in the numerator, gallon in the denominator, and try to avoid writing gallon as G, because then you might confuse it with grams. So, again, we have two units to convert, a length unit and a volume unit. It doesn't matter which one you do first. I typically do the one that's in the numerator, but it doesn't really matter. So if we work with miles first, here's our helpful information. 1 mile, 1.609 kilometers. So I'm going to put the 1 mile on the bottom. 1.609 kilometers. And the miles go away. Now I have to work with, kilometers is fine. That's what I want for my distance or length unit. And then I have to work with volume, gallons. So 1 gallon is 3.78 liters. I need to cross out the gallons, so 1 gallon is going to need to go on the top. 3.78 liters. Gallons gone, gallons gone. And then multiply across the top, divide by the part on the bottom. And you should come up with 12.1 kilometers per liter. So that's our method of dimensional analysis. We use it a lot, so learn it, ask questions, and stick with it, and it'll help you a lot in the long run. Have a good day.